Hi, how are you? I hope you're doing okay. In this video, we are going to work with arrays. We'll see how to initialize an array, either with user-defined values, zeros, ones, or random numbers. So let's start checking the most basic definition of array. It's a special variable which can hold more than one value at a time. And here we have two examples, one dimensional, like this one, and the other one two-dimensional. This one has 3 rows and 3 columns. And by the way, you can call it by its short name 1D and also 2D. Now let's move on and check out the versions of Python and Numpy that is currently running Google Colab. That is the 3.7.13, and in regards to NumPy is the 1.21.6. By the way, NumPy is the fundamental package for scientific computing in Python. To initialize an array and store it in the variable a, we only have to type np.array and put the values inside the square brackets. Here we have two examples, one for one-dimensional and the other one for two-dimensional array. Now, let's start with this most basic example, the one that is one-dimensional array of 6 elements. So I only have to write down the name of the variable, execute the cell, and nothing happens. But if you want to see the actual result, you only need to write down A, and you are going to end up with the array. Now, let's check out some properties that maybe are going to be helpful for you in order to work with arrays. The first one is to check out that actually, that is in fact, is an array. So to do that, we are going to use type. Inside the parentheses, the name of the variable, that is A, and we have the result that actually is an array. Now, if you want to check out the dimension, it's very easy also. We only need to call the array by its name, a.ndmin. So we are going to end up with the number 1 here because we only have one dimensional array. Now, if you want to see how many elements do you have inside the array, you only need to write down .size and execute the cell, and we have the 6 elements that we already defined. Another option that is very useful is shape, and shape allows you to see how many rows and how many columns do you have. In this case, we only have 6 elements, so we only end up with the number 6. And finally, if you want to check out, well, what kind of data do I have inside the array, we are going to use dtype. So in this case, we only have integer numbers, so we end up with this result. Now let's move on with the defined values for arrays in case you want to initialize the array with ones, zeros, or if you want to use only empty. It's going to be very easy. You only need to have one parameter inside the parentheses, and we are going to work with very simple example. Let's start with the ones, and if you want to have 3 ones in the array, it's going to be like this. The name of the array, np.ones, number 3, because we only are working with one-dimensional array, so you end up with 3 number ones. On the other hand, if you want to have 6 zeros, you use the instruction very similar as the previous one, and we end up with 6 zeros in the array. Okay, now let's try out the empty. Let's say we have something like v mp.empty. And let's say we have 5 elements that is referring to an empty array. So if we want to check out the result, notice that you don't have an empty array, but you have some values that are randomly generated by the computer or by Python, and these values are going to be float. So if you use empty, just notice that you are not going to end up with an empty array, but you are going to have some random values occupying those places in the memory. Now let's move on with another one that is very useful, another one option. This is the random number generator. Let's say you want to have 7 random numbers between 0 and 5. Since I'm using 0 as a starter, I don't need to use it in the instruction, as you're seeing. Only need to put the top limit, that is 5. By the way, if you want to check out more about the Numpy random option, you can check out this link. I'm going to put it in the description box down below. I'm going to copy and paste the link so you have it, and you can check out the several parameters that we are using right now, or more if you want to know a little bit more about this function. So in this case, I'm going to end up with random numbers that are not inclusive of 5, but you can have 0, 1, 2, 3, and 4, and the size is 7. On the other hand, if you want to define the lower limit, it's going to be very easy. We only need to use one extra parameter, as maybe you are already imagining. This one is going to be for numbers that starts in 1 and end up in 11, because we are not going to be 12 inclusive. The size is going to be 5, and we execute the cell, and here we have the final result. If you want, this is very interesting because notice that every time you execute the cell, you'll get a different values. But if you want to reproduce the same values, we are going to use a special option. By the way, let me do that in order to you to see these results. For instance, every time the cell is executed or the code is executed, you are going to end up with different numbers within the range. But if you want to have the same random numbers every time you execute the cell, it's going to be very easy. You only need to add before the random generator np.randomSeed between parentheses the number 0. And if you execute this cell, it doesn't matter if you run the cell 1,000 times, you are going to end up always with the same numbers. Now let's move on with the two-dimensional array. We are going to work with 2D, and you are going to see that it's very easy. So for this example, I'm going to have an array that has 1, 2, 3 columns but 2 rows. So I'm going to execute the cell, and now you can see it more clearly. Notice in this example that every square bracket holds the values of the row. So if you want to add another row, you only need to put an extra pair of brackets, and inside this extra pair of brackets, the elements that are going to be in your new row. So please notice that we have parentheses, a bracket that is a bracket intended for the entire array. And after that, we are going to add the number of brackets that is needed in order to represent your matrix. For example, here we are working with 2 rows. We only have 2 square brackets with the elements. Now it's going to be very useful if we work with shape, because we are going to have the information of number of columns and number of rows when using this command. In this case, we have 2 rows, as we are seeing here. The first number means the rows, and the second number means the number of columns that you already have in the array. Now, if you want to work as the previous examples with 1, 0s, and empty, for two-dimensional array is going to be very easy, but size must be defined inside the parentheses, and it's going to be the first parameter. So my first example is going to be with 0s. I want to have a matrix 3 by 3. So let's run the cell, and here we have it, a matrix of 3 by 3, 3 rows and 3 columns, and filled with zeros. If you want to work with ones, let's say you have 2 by 2 matrix, it's going to be also pretty similar, but only changing the dimension or the number of rows and the number of columns. So here we have it. On the other hand, if you want to have an empty array, let's use np.empty for a matrix that is going to be 4 by 3. We execute the cell and we have the random generated numbers that are of float type. Now let's move on with the user-defined values to fill an array. If we want to set the same value in the entire matrix, we can use np.full. The first parameter will be the size of the matrix, and the second parameter will be the number to be used to fill the matrix, like in this example. The second option is very interesting, this one, because you can generate random numbers within a range. But notice that in this option, the first parameter is the range and the second one is the size. If we want to have a two-dimensional array, we need to use the parentheses. So let's write down the two examples, one of each one. And let's start with full. I want to have a 3 by 4 matrix full of 2.5. So here we have it. And the second option, I'm going to use random in a matrix that is going to be 2 by 3 size, like this. And I'm going to have the random generator numbers within the range 1 and 5. So I execute the cell, and here we have the result. This is a matrix of 2 rows and 3 columns. Well, that's all for today's video. I hope you find it useful. If so, please like this video and consider subscribing to the channel for more Python related content. Have a nice day and see you in the next one. Bye!